It is our pleasure to welcome you all to this technical sessions of the NBRO Annual Symposium 2024. And we appreciate your presence and look forward to an engaging and insightful session.
Absolutely. These sessions serve as a valuable platform for researchers, scholars, and professionals to share their groundbreaking work, innovative ideas, and insightful discussions on the latest advancements in their respective fields.
In this session, we have a diverse range of topics that promise to engage, inspire, and challenge our perspectives. We are honored to have esteemed researchers presenting their work and look forward to an engaging exchange of ideas.
So, without any delay, we'll move to the technical sessions.
Before we proceed further, I would like to draw your kind attention to the time limitations for each presentation to ensure that we cover all the valuable research being presented today and allot time for meaningful discussions. Hence, we kindly request all the presenters to adhere to the allocated time limit.
As we transition to our first technical session focused on the theme, Transforming Risk Assessment with Advanced Technologies, it's my honor to introduce our esteemed session chair, Dr. Dhanushka Jayatilaka, who will be guiding us through this session. Dr. Dhanushka Jayatilaka serves as a scientist in the Human Settlements Planning and Training Division at NBRO. His academic journey includes a Bachelor of Science degree in Town and Country Planning from the University of Moratuwa, Sri Lanka, a Master's degree by Research at the Department of Civil Engineering from the University of Moratuwa, Sri Lanka, and a doctorate in Civil Engineering from the University of Tokyo, Japan. Dr. Jayatilaka specialized in the areas of geospatial databases and drone-based mapping, nature-based landslide risk reduction approaches, quantitative landslide risk assessment techniques, geotechnical clearance for high-rise constructions. Further, Dr. Jayatilaka is a chartered town planner, and his expertise in civil engineering, geotechnical research, and settlement planning in a challenging and innovative environment. Dr. Jayatilaka's work focuses on the development of sustainable, data-driven solutions for infrastructure resilience and environmental risk reduction.
So I now would like to invite our esteemed session chair, Dr. Dhanushka Jayatilaka, to the head table.
Good afternoon, everyone. It's my great pleasure to welcome you all to the technical session 1, Transforming Risk Assessment with Advanced Technologies. So we have four presentations lined up for this technical session. Basically, they're about the innovative research that integrate AI, machine learning, geophysical modeling, and community-based strategies to improve risk assessment and mitigation. To do the presentations, first of all, I would like to invite Mr. NDC Lakmal, Mr. HWGPT Gamage, Mr. EMKS Ekanayaka, Mr. ARP Veerasinghe to come to the head table. Okay, thank you. So, as the first presentation, we are going to listen to the evaluation of performance of real-time air quality monitoring sensor in different environment conditions for the development of correlation. The presentation will be done by Mr. NDC Lakmal, Scientist of Environmental Research and Services Division of NBRO. Floor is open to you.
Very good afternoon, everyone. And I am NDC Lakmal from Environment Division. In disaster management, one of the key areas to be considered on man-made disasters. Out of man-made disasters, air pollution is one of the concerning phenomena in worldwide, since it is highly correlated with human health, biodiversity change, climate change, and etc. In air quality monitoring, real-time sensor-based equipment are the smart technology popularizing in worldwide. Therefore, our research is on evaluation of performance of real-time air quality monitoring sensor in different environment conditions for the development of correlation. Several techniques are used for air quality monitoring in worldwide. Some are reference grade method and some are non-reference method that used along with reference method with validation. Usually, reference grade method provide high data accuracy and reliability and have high cost infrastructure, service and maintenance. The non-reference method are low cost compared to the reference grade method but have low data accuracy. Therefore, non-reference grade method are not used for regulatory purposes but can be used for ambient air quality monitoring with validation of reference grade monitors. When considering air pollutants, the criteria air pollutants are particulate matter, nitrogen dioxide, sulfur dioxide, ground level ozone, and carbon monoxide. And this figure shows the worldwide dispersion of particulate matter, nitrogen dioxide, and sulfur dioxide levels. Considering WHO guideline levels, the lowest values were given for the particulate matter compared to the other pollutant levels. Therefore, more priority has been given to manage particulate matter levels in ambient air. When considering Sri Lanka, according to our previous studies, the critical pollutant is particulate matter, which sometimes exceed Sri Lankan standard. Therefore, we have developed a low-cost sensor unit especially for particulate matter analysis since it has several advantages compared to the other low-cost sensors in the market. They are low-cost, easy to calibrate to our environment condition, repair and troubleshoot, no dependency on third-party service and maintenance, easy to integrate with other custom-built system or third-party platform, and etc. Beta attenuation monitor, known as BAM, is one of the widely used reference-grade real-time technique for ambient air quality monitoring in the worldwide. The principle behind beta attenuation monitor is that energy is absorbed from beta particles as they pass through particulate matter collected on filter media. Beta ray can either be absorbed, reflected, or they can pass through a material. The concentration of material present determines how much beta ray intensity is attenuated. Light scattering technique is used to calculate the particulate matter concentration in low-cost sensors. Light beam is scattered depending on the size of particles go through the light beam. The main objective of this paper are to validate the sensor unit by correlating with the reference grade beta attenuation monitor, evaluation of performance of low-cost sensor in different environment conditions to check the data accuracy and reliability, introduction of validated low-cost sensors to the existing air quality monitoring network to enhance the monitoring capacity. Methodology. Co-location experiment was done in Colombo area for the validation of sensor unit. We take more than 1 month data for development of correlation between sensor unit and BAM. In addition, a performance evaluation of multiple sensors was done in Battaramulla area, CEA reference grade laboratory at CEA Battaramulla area, and another study was done at Anuradhapura area for 1 week period. Also, performance evaluation in other areas are continuing with an island-wide monitoring program. Validation was done according to the method given by US EPA, and the evaluation was done according to the NF ISO 13528 standard. Score set and number EN values were used to confirmation of performance of each sensors. The results of validation study indicate a good correlation between both measured values and recommended daily and hourly correction factors are given in following table. The goal of this development is to get one-to-one relationship between sensor and BAM data. After that, we have introduced this developed correlation factor for our sensor units. This graph shows the time series analysis of measured 2.5 values on low-cost sensors and BAM in Battaramulla area. The multiple performance evaluation of PM 2.5 data in Battaramulla indicate the same trend and variation in all sensor units with BAM. The statistical evaluation of data indicates that R squared value greater than 0.95 between sensor units and R squared value greater than 0.88 with BAM unit. Measured score Z and number EN values indicates the sensor unit are well performed as data indicate in the table. Similar test was applied to the PM10 levels. The statistical evaluation of data indicates that R squared value greater than 0.94 between sensor units and R squared value greater than 0.86 with BAM unit. Measured SCO Z and number EN values also confirm the sensor unit are well performed as data indicate in the table. Performance evaluation study at Anuradhapura area also indicated the similar trend and good correlation with low-cost sensor and BAM. These are the conclusion of the study. The data collected by low-cost sensors are highly correlated with the reference grade monitoring equipments. Hence, low-cost sensor can be used to ambient air quality monitoring with reference grade monitors. Low-cost sensor shows high performance in different environmental conditions. Therefore, these low-cost sensor can be used to develop monitoring network in the country. And data were dissemination in different communication platform to aware the general public and stakeholder institution. And this monitoring network will be expanded further up to 100 units in island-wide with the assistance of World Bank funds. And these are some references used for this study. And thank you for the listening.
Thank you, Mr. Lakmal, for your interesting presentation. We'll move to the questions after the all four presentations. So I would like to cordially invite to Mr. HWGPT Gamage to present the development of advanced landslide susceptibility mapping methodology using machine learning and AI tools, Kagol district. Mr. Gamage is a scientist of landslide research and risk management division of NBRO.
Good afternoon, everyone. My name is Pramod Gamage. I am here to present our work on developing an advanced landslide susceptibility zonation methodology for Kagol district using machine learning and AI tools. These are my contents. For introduction, this map shows reported incidents in Sri Lanka considering landslide. Landslide, one of the most significant natural hazard in Sri Lanka, which cover the 30% of the total land area and 38% of the total population of Sri Lanka. So, landslide susceptibility zonation is important for identification of susceptible slopes for failures that used for overall risk management efforts, such as risk assessment, risk categorization, and selection of risk treatment options. So, our current methodology implemented by NBRO is laborious, expensive, and cannot be frequently updated. So, in this study, we present to target these above issues. So, my main objective is to develop an advanced landslide susceptibility zonation methodology using machine learning and AI tools from LiDAR-derived variables. These are my specific objectives. For study area, we select Kagol district, which has more than 1 million people with population in hilly areas. Considering landslide history, this district is frequently affected by landslide, especially during southwestern monsoon. This landslide, which we have shown here is Aranayaka landslide. It is also one of the largest landslide recorded in Sri Lanka. Is also happened in Kagol district. For my methodology, we first filtered the existing landslide inventory and confirmed them using Google Earth. Then selected the equal number of landslide points and non-landslide points as dependent variables, considering on the landslide initiation area. Then 70 points from each type excluded from analysis for validation. Then we extract 12 independent variables using LiDAR 2-meter depth. Then, based on significance and literature, selected 9 variables. After that, applied 6 machine learning models and select the best fit model. Then, generated susceptibility score from the best fit model and finally reclassified into susceptibility zones. These are the 9 variables I selected for this analysis, and these are the 6 models here used. For model discrimination, we use area under the receiver operating characteristic curve and precision recall curve. This AUROC is a good measure overall, and also PR curve is more sensitive to outperform on the positive class, which is the landslide, and which is the class of interest in this study. This green color line represents the random forest, which has the highest value. So both curves suggested random forest have excellent discrimination. By comparing accuracy and precision of these 6 models, we can assume random forest has the best accuracy and F1 score. Accuracy means the overall percentage of correctly classified landslide and non-landslide points. F1 score means balanced measure of precision and recall. So, accuracy and precision assessment also confirm random forest is the best model. Then by literature, random forest consistently outperforms the other machine learning models in landslide susceptibility studies because it handles non-linear relationships and it is robust to overfitting and have high accuracy in fast analysis and implicit feature importance and handles high dimensionality. Also, it is relatively few hyperparameters used and easy to tune then. So past literature also have promising result regarding these random forest models. This is the basic understanding of what is random forest model and concept of random forest. Then for model validation, cross-validation was used. This is a technique to assess how well the model will generalize to new unseen data. We use 5-fold cross-validation here, and process is repeated 5 times, which each fold serving as the test set once, and to get more robust estimate of performance than a single train and test split. This table shows us 5 folds accuracy and precision. So these results showed consistent performance across all folds with an average accuracy of 89% and average AUROC value of 0.95. Then model validation was done by calibration. Calibration refers to how well the predicted probabilities from the model match the observed frequencies of the landslide. This model shows good calibration in low and high risk areas, but there is a slight underestimation in mid-range probabilities. If the model is poorly calibrated, the predicted probabilities won't accurately reflect the true likelihood of the landslide. But apart from this around 0.3 and 0.5 values, this model lies closely between perfect calibration line. Using this validate model, we generated the map for entire K-Gold district. For that, we reclassified into 4 susceptibility zones, and this reclassification is done considering cumulative area of high susceptibility zone to be less than 10%. This table shows the cumulative area of these 4 zones. So validation, 74% of landslide points were located with high and very high susceptibility zones, and 71% of non-landslide points were located within low susceptibility zones. So conclusion, LiDAR-derived variables and machine learnings can be effectively used in this type of study. In this study, random model shows the most promising result among tested 6 models, which achieve the highest accuracy and have excellent discrimination. Also, model validation confirm this, but improving more landslide data and consider about other relevant data such as geology, hydrology, land use, landform can improve this model further. Also, it is advisable to consider specific terrain and environmental condition when extend to different regions. This is my acknowledgement. These are my references, and thank you for your attention.
So I would like to invite Mr. Ekanayaka, Scientist of Human Settlement Planning and Training Division, to do the next presentation. His topic is evaluating the effectiveness of community-based approaches in enhancing community resilience in landslide high-risk clusters.
Good afternoon to you all. Today I am honored to present our research on evaluating the effectiveness of community-based approaches in enhancing community resilience in landslide high-risk clusters. This research explores how community-based initiatives can improve the resilience in vulnerable areas. Disasters, especially landslide, pose a significant threat to the communities. Therefore, community-based approaches plays a significant role as a proactive measures in disaster risk reduction. CBDRM is a process in which at-risk communities are actively engaged in the identification, analysis, treatment, monitoring, and evaluation of disaster risks to reduce their vulnerabilities and enhance their capacities. In this regard, the involvement of most vulnerable group is essential for successful implementation. However, the most of studies conducted in Sri Lanka identified that the current CBDRM approaches has less significance due to several reasons among implementing parties and the community. The NBRO also observed that the inclusion of landslide high-risk families in the current CBDRM process is significantly less. Therefore, the NBRO has launched a community-based landslide risk management program to reduce the adverse impact on landslide high-risk communities until they are resettled. Initially, we have identified about 325 landslide high-risk clusters for this program. These clusters include landslide high-risk families who have been recommended for the resettlement. However, due to slow progress of current resettlement program, they continue to live in same high-risk areas. Therefore, we identified that these high-risk families are the most vulnerable groups requiring community-based approaches, especially to reduce their impacts, especially during the rainy season until they are resettled. So in this program, main key activities we are conducted are establish CBDRM for landslide high-risk clusters, which has more than 10 houses, and prepare community-based landslide disaster management plans, and distribute rain gauges to communities and enhance self-decision-making capacities, and community awareness on preparedness and emergency response, and establish online application to share the information and rainfall data, and improving the accuracy of the early warning issuance with this rainfall information, and implementation and continuous monitoring for the sustainability of the program. So this is the distribution of those high-risk clusters in district-wise. Initially, we have implemented the community-based approaches in Badul and Ratnapuri district in phase 1 for 119 clusters, and the program has highlighted the critical need for the deeper understanding of community dynamics, effectiveness of strategies, and the challenges in the implementation. Therefore, we wanted to understand and identify how effective are the community-based disaster risk management programs in enhancing community resilience in landslide high-risk clusters, developing a proper methodology, and what are the challenges in implementation. So these are the key objectives of this research. One is to identify the key factors influencing the effectiveness of community resilience through a literature review, and to assess the existing community capacities and vulnerabilities related to the landslide risk, and to evaluate the effectiveness of the implemented community-based strategies enhancing community resilience, and finally to provide recommendation for improving the design, implementation, and monitoring of community-based approaches. To achieve these objectives, we have followed the comprehensive research process, and initially we have conducted the literature review, and through the literature review we have developed the resilient assessment methodology, and then we have applied this methodology to the community-based interventions. And for this one, we have selected 119 clusters in Badul and Ratnapura district. Already we have established the community-based approaches. And then we have conducted the impact validation with a baseline assessment and post-intervention assessment. And then we have provided the recommendation and way forward based on the results. So first we have conducted the comprehensive literature review to identify the indicators in the resilient assessment. And we have identified factors such as presence of structured community organization, participatory decision making, disaster management planning under the governance and planning dimensions, and well-established early warning system, real-time database data sharing, community safety infrastructure, resilient built environment and the technical capacity, and community cohesion, collective adaptive response, pre- and post-disaster preparedness as social and community engagement dimensions, and sustainable land use, slope stabilization, relocation strategies, and conservation practices under the environmental and physical resilience dimensions. So with these factors, we have identified 17 indicators related to the community-based approach we have established. So after that, we have organized those 17 indicators into a 4-level hierarchical structure to evaluate the status of each cluster. We have used brainstorming session and expert discussion for this process. If the community has installed the rain gauge and monitoring and record rainfall data and connected it to the online rainfall dashboard and data feed into the applications and share the rainfall information within the community, they have considered as a level 1 community. If community has appointed a DM committee, prepared DM plan for clusters, available of evacuation centers, and community participation is available, they are considered as a level 2 community. If the committee meetings held as per the plan, and if they have taken actions in pre, during, and after monsoon as per the standard operating procedure developed by NBRO, and if the community-based mitigation measures have been implemented, they are considered as a level 3 community. If the land is available for resettlement, houses construction in progress or already resettled, they are identified as the level 4 community. With these indicators and the community levels, we have developed a cluster resilient matrix. In this matrix, the gain line or a level 4, if the community has achieved level 4 or in a green line, they are considered as a high resilience community. And the level 1, 2, and 3 level communities means they require some essential indicators to achieve or to improve their resilience level. And the red line means they did not meet any indicators in the resilience. So with this matrix, we have collected the information from 119 clusters to assess their resilience level based on 17 identified resilient indicators. Comprehensive and temporal analysis method used for the analysis, and we have analyzed this cluster resilience level before and after implementing the community-based programs. Our findings is that the sum of the clusters exhibit a high baseline resilience level requiring only monitoring programs And most of the clusters initially lacked baseline resilience. However, their resilience levels improved following the implementation of our community-based approaches programs. When we take into this into the metrics, 68 clusters have been achieved to level 1 resilience from the bottom, and 39 achieved to level 2 from the red line. And also another 11 clusters before they were in level 1, and out of them 2 were remaining in the same level, and the 5 achieved level 2 and 4 achieved level 3. And 3 clusters were in the level 3 and remaining in the level 3 after the implementation of community-based program. However, they need more attempt to achieve the high resilience level or to achieve their level 4 green line. Further, we have introduced online applications to share their rainfall data with the NBRO Early Warning Center, and also this is the assessment of their response level. This is during rainy season in October and November in 2024. This is the data submission rate for the connected locations. We have connected about 90 rain gauges to our system. Out of them, 55% of the connected sites successfully transfer data in Badula district, and 45% of the connected site transfer their data in Ratnapura district. Based on these findings, we can conclude that prior to the implementation of community-based approaches, 90% of the clusters did not meet the resilience indicators. However, after the program, 57 of the clusters achieved level 1 resilience, 37 of the clusters reached level 2 resilience, and 10% of the clusters has had prior experience with the resilience indicators and further improved their resilience level through the programs. And 3 clusters met all resilience indicators up to the level 3 before program's implementation. And further, we have identified several challenges in implementing these resilience indicators. Those are difficulty in measuring rainfall during heavy downpours or night time, and connectivity and data package issues affecting rainfall data and information sharing, and limited community engagement and lack of interest, and various evacuation related challenges, especially including flooding the evacuation roads, the measuring difficulty in measuring rainfall data by using manual rain gauge is one of the main issue identified through this literature. Therefore, we have technically intervened for this issue and introduced a semi-automated rain gauge with the collaboration of Leo Club of University of California to tackle this issue. So this semi-automated rain gauge consists with 3 parts. One is manual rain gauge and the measuring sensor and the remote display. This remote display can fit in the living area in the house. And during the rainy time, the display, the rainfall levels will display on the remote display. And when it's reached 75 millimeter level, the yellow LED will illuminate, and when it's reached 100 millimeter level, the amber LED will illuminate, and red LED will indicate the rainfall has reached 150 millimeter level, which means evacuation level. And after the 250 millimeter levels, you will hear the continuous beeping. This is still under development, and with more calibrations and development, we are supposed to introduce this into community for the self-decision making of the community and improve their resilience. So finally, with these findings, we are identified. This is actually this assessment was done. This is basic level assessment with the hierarchical levels, and this should be incorporate a comprehensive resilience assessment framework, such as a cluster resilience index, to systematically evaluate the governance, technical and social and environmental factors, and also scale up the use of digital tools such as strain gauges connected to online dashboard, WhatsApp groups, and mobile apps for real-time data sharing and early warning dissemination. And appreciation and recognition of the community contributions for their actual participation, active participation, and also establish robust monitoring system to track the progress of resilience building activities such as committee meetings, pre-monsoon preparedness, and mitigation measures. Thank you.
Thank you, Mr. Ekanaika, for your very interesting presentation about community-based approaches. Our next presenter is Mr. ARP Veerasinghe, Geologist, Geotechnical Engineering and Testing Division of NBRO. He's going to present about the integrated 3D geophysical and hydrogeological approaches for landslide assessment and mitigation, a case study of the Malittagolla landslide, Badulla district in Sri Lanka.
Good afternoon to you all. My research topic is integrated 3D geophysical and hydrogeological approaches for landslide assessment and mitigation as a case study of the Malittagolla landslide, Badulla district in Sri Lanka. As the background of the study, in Sri Lanka, mostly landslide is a major geohazard affecting the country. So most of them are triggered by the rainfall and causing threat to human life and property and infrastructure. Most of the studies have been done in the past on landslide targeting the mitigation approaches, but they are mostly lack of in 3D approaches. They most only relied on 1D or 2D methods, limiting the spatial understanding. So also some insufficient ground note analysis, so the ground note in slope stability is not fully understood. And the poor correlation between the geophysical, geotechnical and hydrological finding also there, so it is need to be done. So why do we need a 3D model? And it's their integration. So actually it enhances the spatial understanding, like detailed representation of the subsurface structure and more accurately than the 1D or 2D method. So we can do the better ground note analysis, like in the precise tracking of the ground water flow, improving the understanding of roll and slope stability, and improved hazard prediction. So combining geophysical, geotechnical, and hydrogeological data in the 3D model, we can reduce the uncertainties and lead into more reliable landslide assessment. And also stronger mitigation options, like using the 3D model, we can allow in the better mitigation strategies. So objective of the study, our objective of the study is to integrate the topographical, geophysical, and hydrological data and analysis to understand the landslide dynamics in 3D and develop effective mitigation strategies and establish a framework for managing similar landslide-prone areas. Our study location is Malittagolla landslide. It is located in Karandagolla GN division, Badulla district. And it has a mix of steep and gentle slope. And the Ellavaya main road is situated downslope, making it highly vulnerable. So recent activation recorded in May 2024, November 2023, and December 2019. Sorry. There's a video on, okay. No problem. These are some of the photographs of the landslides. Let's move to methodology. This study combines several methodologies: topographical, geomorphological, and mapping, including field mapping and UAV surveys, landslide mapping, digital elevation model, and to create the digital elevation model and author images. And we have done the geophysical investigation, like electrical electricity tomography, and it's identified the groundwater saturated zones and subsurface strata, and seismic refraction tomography to identify the bedrock structures and geometry, and hydrological studies like installation of piezometers and surface flow monitoring using V-notch vias. And also we have done the ground deformation and displacement monitoring using a total station. As you see in the map, in the blue color line shows the landslide geophysical survey lines. So we selected these lines based on the landslide moving directions and the gridded patterns. So let's talk about 2D models. And from the field data, we can produce 2D models. As generally, electrical resistivity tomography shows the ground electrical resistivity variation. So in the low resistivity zone, we can send groundwater or seawater intrusion or groundwater saturated zone or highly conductive materials. In the high resistivity zone, bedrock or low conductive materials can be found. And in between that, soil or moderately conductive materials can be found. In the seismic refraction tomography, generally, it shows the seismic P-wave velocity variation. And in the low velocity zone, shows the loose or not compacted materials. On the high velocity zone, we can find the hard rock or hard materials. And in between that, medium to high density soil can be found. So first, these field data is used to create 2D models, 2D profiles using the analysis. And after that, 2D ERT profiles was to make it into the 3D model using the empirical basin trimming 3D method. Empirical basin trimming method is a spatial predicted method that estimates the value in the 3D space using statistical modeling. As you can see, these are the results from the 3D ERT or SRT model. Let's understand them separately. From the 3D ERT model, as you can see in the map, the blue color is showing the low resistivity zones that where the high groundwater concentration is we found. So also the blue color area also within the landslide body area. The concentration is within the landslide body area. So this is also a good find into the groundwater is a key factor in the landslide instability. Let's move on to the seismic results. In the P-wave analysis, red color show the high P-wave velocities, and it indicates the denser material such as bedrock, and the low P-wave velocity green to yellow color. This represents less dense materials such as soil. As we then extracted from the 3D SRT model as a color contour bedrock surface model. So we can see the bedrock are some like barrier-like feature in the geometry. So also this landslide show landslide movements obstruct and redirected from the this, and also follow the valleys-like feature in the geometry. So let's integrate the ERT and SRT result. As you can see in the image, where first in blue color is the ERT, then SRT and the combination of integrator. And you can see also in blue color region is concentrated within the landslide mass and the movement direction like valley-like geometry. So also, let's move to the result of the hydrogeological and movable points. And we install V-notch vias to measure the water inflow and outflow from the landslide, and it's revealed in the graph. There are huge difference in the inflow and outflow. That means there's a significant groundwater release from the landslide. And also during this even the dry period, there were many springs and water coming from the landslide, and also there are movements observed despite the minimal or no rainfall in the May 2024. And these findings suggest that internal groundwater dynamics also can drive the activation of the landslide. Also, all things emphasize that there is a need of effective groundwater management strategies for mitigation. So, we propose mitigation measures. Introducing 3 drainage wells are our proposal for. As you can see in the image, drainage wells including lateral drains. As in the pink color, in the 3D model, we can see the drainage wells, and using the lateral gravity drains, we collect water from the landslide area to the drainage well and redirect them from the groundwater discharge from the nearby stream or drain. Additionally, we have to measure like another slope stability like retaining structure for high movement zones. So, as a conclusion of this study, integration of SRT and ERT data enhance the bedrock geometry, structure features, and groundwater behaviors. Groundwater dynamics play a critical role in the landslide and its activation. Effective mitigation requires subsurface drainage to control groundwater pressure and improve soil stability. The developed framework provides a total effective landslide mitigation in similar vulnerable areas. Additionally, these 3D geophysical approaches can be applied to various geotechnical and geological and hydrogeological applications. These are some references, and thank you.
Okay, thank you, Mr. Veerasinghe. We have listened to all 4 presentations which are supposed to present at this technical session 1. So now I would like to open the floor for the few questions, maybe one question from each presentation. If you have any question, please raise now. Okay, until your questions getting ready, I'll ask one question from Mr. Gamage. So you talk about machine learning technique to identify the landslide susceptible areas using some LiDAR dataset and the AI model, random forest model. I would like to clarify whether is that model capable of capturing dynamic factors such as some variation in the factors, maybe the rainfall or some other dynamic factors?
Yes, in this model, it has not that capabilities because we have dynamic factors. We have to do with dynamic modeling because rainfall is a time-driven factor. So we have to dynamic factors. So we have to consider the rainfall threshold to use in that these type of analysis. So we have to combine these type of analysis to this rainfall threshold, and then we have to incorporate dynamic modeling, and then we have to incorporate these rainfall like factors. But also we can try to get the cumulative rainfall, and it can be incorporated these type of models, but it has to be precise data on cumulative rainfall data when and what date actually these landslides have happened.
So is there any question from the audience?
Actually, this is not a question but a suggestion. This is for the 4th presentation made by Mr. Ranjan. So as we all realize that landslide, that is Malithagolla, was generated by, not due to rainfall. It was a drought season when that landslide, the time when that landslide took place, it was totally due to groundwater impacts from the groundwater. That's what we have to realize. So actually, as an immediate impact, we actually apply some short-term mitigation measures to remove the groundwater out from the sliding mass. And actually, we got the positive results by seizing that rapid movement into the Vallavaya to Bandarala main road, and also with the further analysis, we realized that that was totally due to groundwater impacts, not due to rainfall. That was just as Mr. Gamake mentioned, cumulative rainfall is, as we know, in general, that is the major influential factor of landslide here in Sri Lanka. But in addition, we also have to think of the effect from the groundwater. That is a separate subject, it's called hydrogeology. Even during drought season, we can anticipate such a major landslide purely due to groundwater impacts.
Do you have anything to add, Mr. Veerasinghe?
As Ken sir mentioned, it's very true. And this landslide actually, as we say in the field, there are many spring shows, even the dry period. So, and very active during the period of mostly sometimes it's 1 to 2 meter per day displacement can be found in this landslide. Actually, this is activation is mostly done by the groundwater dynamics. Thank you.
Do you have any more questions from the audience?
Good afternoon. I'm Kaushal from WFP. I have a question for, I think, Mr. Ekanayake. Now, I think some time ago, maybe in 2018-19, DMC, they developed a resilience framework, a community resilience framework. In the design, what you proposed for CBDRM landslide preparedness, I want to know how far you have been considered. I mean, you have considered the framework. It was proposed by, I think it's now approved as far as I know. Further to that, I also want to ask now, when I see the clusters indicators, where you have classified them into 4 stages, now in the resilience framework, as far as I remember, we considered several aspects, like the social aspects, human aspects, physical aspects, socio-economic aspects, likewise. So what I see in the design, what you show in the cluster, more into the physical aspects. Have you considered other aspects when you have, when you are developing this model for resilience measurement, this resilience status measurement? Another question maybe, if you can answer. Now, what I see also in the design, what you propose for early warning, so there's I think a gadget, maybe a equipment developed for obtaining early warnings, and that basically triggers with the rainfall. So how just the rainfall only can be a measurement? Because, for the landslides, there are other aspects we need to consider, the steep level, the soil conditions, many other aspects, I would say. So as people need to take decisions, how can only the rainfall can be a trigger? Have you considered other aspects into these, into this trigger, early warning, the message that are going to get through these equipments? And I also want to ask now when it comes to preparedness level, now anticipatory action is something new, which is under discussions. I think, have you considered any anticipatory actions where you can measure the preparedness level? Maybe a few questions I ask. Thanks.
Yeah, thank you for the question. The first one is actually we have reviewed the published article to identify the indicators. I think DMC one also one of the framework we have identified. And with those published articles, published framework, we have derived what are the suitable indicators, suitable factors for our community-based approach, because we are here we have considered the high-risk families who have identified for the resettlement, because we have introduced this CBDR process until to minimize their impacts until they are resettled. So we wanted to identify what are the real factors to measure their resilience level, those high-risk families. So that's why we developed this one, and also we have and further, this is the basic level. We have developed only a 4 hierarchical level. This is not the high accurate level. This is a basic level. What we wanted to do is to identify their levels at this moment. So we want to develop, as I mentioned in my conclusion, this want to develop as a matrix. We want to give a weighted, and also we have identify further if we have missing areas, like we have said, because in this level we have considered all of these aspects, and also with the brainstormings and with the consultation of experts. So yeah, still this is also, this indicators also is under development. But this is the baseline, this is the basic level we have developed to identify the resilience level. So in future, we are trying to develop this as a matrix, given a weighted and also identify the missing indicators, missing areas. And also another question, right? Rainfall about the, as a early warning measure. So I think it's better to get an answer from the, yeah.
So the second question mainly related on why we consider only the rainfall measurements, because we selected these communities based on the hazard maps as well as the landslide symptoms areas. So in that means we consider there are 6 factors. Like now there we consider 6 factors for preparation of landslide hazard zonation maps called susceptibility maps. So based on these susceptibility maps, we issue the early warning. So that's why we consider only rainfall. And these communities are already identified, like now there are a lot of symptoms, and these communities has a lot of, we need to build their capacity. So that's why we are issuing early warning based on the rainfall indicators. But they know they have some kind of symptoms, and they have some idea about how the landslide occurs. They can understand what is the landslides. So those kind of awareness they have at the moment. And the third one is related to the anticipated reactions. So we have considered about there are another research on anticipated reactions, what are the anticipatory actions that we can identify. So so far we have identified 12 actions. So that also presented in another research paper. So if you can go to the proceedings, so there is another research paper. So we also considered that part as for this community-based approaches. Thank you.
Thank you, Dan. Adding some more information to the answer. Whether we have spent our allocated 1 hour, I would like to give opportunity to ask one quick question from Mr. Lakmal for the fairness. Do you have any question from Mr. Lakmal? Seems no. Shall I ask one? Yeah. So you talk about development of low-cost air quality monitoring sensor. So I'm expecting very quick answer from you that what are the principles behind the developing this sensor? Whether it is cost, do you, your aim is to reduce the cost or increase the robustness? What kind of the design principles behind the development of that development?
Yeah, the main purpose of this development is to use those sensors for our monitoring network, since we cannot afford some reference grade equipment. And yes, this developed sensor is low cost compared to the other low cost sensors in the market. and have same kind of features in it.
Thank you. So, with that, we are going to conclude the technical session 1. Thank you for all the panelists for their presentation and active involvement in the Q&A session.
We would like to thank you, our esteemed session chair, Dr. Dhanushka Jayatilaka, for his valuable guidance and leadership throughout the session, and as well as the presenters.
Now, as we conclude this enlightening technical session, it's time to recognize and appreciate the efforts of our esteemed presenters.
Yes, indeed, their dedication and contributions have significantly enhanced our knowledge, and we sincerely thank them for sharing their valuable insights with us.
Therefore, I kindly invite Dr. Dhanushka Jayatilaka to present the certificates of appreciation to the presenters. Presenters, as your names are called, please come forward to accept your certificates. Mr. N.D.C. Lakmal, Mr. H.W.G.P.T. Gamage, Mr. E.M.K.S. Ekanayaka, Mr. A.R.P. Veerasinghe.
Dr. Dhanushka Jayatilaka, please remain on the head table for a moment. And I would like to invite Director General, Disaster Management Center, Major General Uday Herat, to present the token of appreciation to the session chair, Dr. Dhanushka Jayatilaka. Thank you very much. Now we are moving on to the second technical session. It is under the theme of Innovation in Action for Sustainable Environment.
Accordingly, it's my honor to introduce our esteemed session chair, Engineer Dr. Sanchita Jayakodi, who will be guiding us through this session. Engineer Dr. Sanchita Jayakodi serves as a geotechnical engineer in the Geotechnical Engineering and Testing Division at NBRO. His academic journey includes a Bachelor of Science degree in Civil Engineering from the University of Moratuwa, Sri Lanka, a Master's degree in Foundation Engineering and Earth Retaining Systems from the University of Moratuwa, Sri Lanka, and a doctorate in engineering from Kyoto University, Japan. Dr. Jayakodi specialized in the areas of geotechnical investigation and testing, soil mechanics, designing of foundations, earth retaining systems and ground improvement, physical and numerical modeling, rainfall-induced landslides, and landslide risk reduction. Further, Dr. Jayakodi, a chartered civil engineer, brings nearly a decade of experience across industry and academia. His work focuses on integrating practical and theoretical knowledge to address complex engineering challenges while advancing sustainable practices.
So now I kindly invite Engineer Dr. Sanchita Jayakodi to the head table.
Good afternoon, everyone. So this second session, so the theme goes as Innovation in Action for Sustainable Environment. So I would like to invite all four presenters to the head table. So first, Ms. W.C.M. Imalsha, engineer from Geotechnical Engineering Division. Ms. E.P.T. Pathirana, engineer from Building Material Research and Testing Division. Ms. H.A. Pathirana, engineer from Structural Engineering Research and Project Management Division. And the last, Mr. C.J. Veerasena, scientist from Building Material Research and Testing Division. So just to remind you all, so the one presentation will be 10 minutes time, and we'll have a Q&A session after all four presentations. The first presenter is Ms. WCM Imalsha. So her topic is evaluation of residual shear strength of landslide soils in Passara Bibile area using ring shear test. So stage is yours.
Good afternoon, everyone. My research topic is evaluation of residual shear strength of landslide soils in Sri Lanka using ring shear tests. This is the content of the presentation. Let's go through one by one. First, let's see the introduction part. Landslide are one of the most significant natural hazards in Sri Lanka. In this picture, you can see the Aranayaka landslide. This landslide was happened in 2016. This completely buried part of the several villages and killed around 125 people and destroyed many houses situated in the flow path. Therefore, it is essential to assess runout path for rapid and long traveling landslides. Various software tools have developed worldwide for flow path predictions. Among them, LS Rapid is one of the most commonly used simulation tool. For LS Rapid simulation, peak and steady state shear strength parameters are required as inputs. For obtain those parameters, ring shear apparatus is the ideal one. ICL2 undrained ring shear apparatus and LS Rapid software donated to the National Building Research Organization under the SACTRAP project in 2022. In here, you can see the two examples where NBRO accurately predict landslide runout path using LS Rapid software. The first image shows the Aranayaka landslide prediction, and the second image shows the Atvalthada landslide prediction. Here you can see the ring shear apparatus. This apparatus is a specialized laboratory equipment to determine residual shear strength of soils. This simulates large shear deformation under control condition. This picture shows the ICL2 ring shear apparatus in the NBRO Geotechnical Engineering Laboratory. Anyone can download the operation manual. It's free to available in Google. Now let's see the aims and objective of this research. Aim of this research is to evaluate the residual shear strength properties of soils in landslide prone areas in Sri Lanka using ring shear test and to investigate the influence of soil composition on shear behavior. There are two objectives. First one is to determine the residual shear strength parameters of soils from selected landslide location using undrained ring shear test for LS Rapid simulation. Second one is to investigate the relationship between soil composition and shear behavior, including mobilized friction angles and steady state shear resistance. Now let's see the research methodology. First, 4 landslide locations were selected along the Passara Bibila road area in Sri Lanka for the study. Then soil samples were collected from identified landslide locations. Then index property tests were conducted on the collected soil samples. After that, mobilized friction angle, steady state shear resistance and shear displacement characteristics were analyzed. Finally, effective stress path and brittleness indices were determined and compared. In here you can see the focused area. This research was conducted focusing especially on case studies along the Passara Bibila road in Sri Lanka. This region experienced significant landslide situation during heavy rainfall events in December 2023, activating 4 notable landslides due to that. These are the photographs of the selected 4 landslide locations. Now let's see the laboratory testing part. The residual shear strength behavior of landslide soils were investigated through undrained ring shear test conducted on the soil samples obtained from landslide locations. First done the index property test and CV analysis and Atterberg limit test. Then done the ring shear test. For that I use ICL2 undrained ring shear apparatus with the maximum loading capacity of 1000 kilopascal. For testing, dry soils passing through 2 meters was used. Saturation was achieved using DER water in a vacuum tank. Then BD value is checked to measure the degree of saturation. Most difficult part of this saturation procedure is for high fine content soils takes more time for the saturation procedure. Then soil samples were consolidated to simulate the initial stress condition of the sample. Then done the monatomic shear stress control test under saturated condition. For that I use shear strength increment rate of 0.25 kilopascal per second and the effective normal stress as 100 kilopascal. In here you can see the test results for index property test results. Here you can see the location A has a fine content of 47%, location B has fine content of 27%, and location C and D has fine content of 30%. Here you can see the ring shear test results for location A. First graph shows the shear stress versus effective normal stress graph. From that graph we can obtain mobilized friction angle during motion and the mobilized friction angle during peak stress, and also we can obtain the steady state shear resistance as indicated in here. Second graph is the shows the time series curves for total normal stress, shear stress, forward pressure and shear displacement. Third graph shows the third graph is a shear stress versus shear displacement graph. This shows from that graph we can obtain shear displacement at the start of strength reduction and the shear displacement at the start of steady state. In here you can see that undrained ring shear test results for the soil samples of 4 landslide locations. These are the parameters required for the LS rapid simulation. Now let's see the discussion part. In here you can see the shear stress versus effective normal stress graphs for all 4 landslide locations. From that, the effective stress path obtained from the undrained ring shear test shows the mobilized friction angle during motion tend to decrease with the increase of fine content. In here you can see the shear stress versus shear displacement curves for all 4 landslide locations. From that we can say shear strength decrease with the increase of fine content and peak strength decrease with the decrease of the fine content. And also we can see that location C and D have same fine content, but the D contain more gravel compared to C. Therefore, peak strength a little bit reduced in the more fine content graph of D. In here you can then I calculate the brittleness indexes for all landslide location using this equation. Brittleness index is the tendency to lose strength after reaching its peak shear strength. This index is commonly used to assess the behavior of soils in landslide prone area, as brittle soils are more likely to undergo sudden and catastrophic failures. According to the literature, soils with higher fine content exhibits an increased brittleness index. However, in this study, this trend was observed to some extent, but more data is needed to confirm it. Now let's see the conclusion part. After doing ring shear test for all landslide location, following conclusion were obtained. As fine content increases, the mobilized friction angle during motion decreases, and also shear strength decreases with the higher fine content, while soils with lower fine exhibit higher peak strengths, and also brittleness index increased with the fine contents was observed to some extent. Ultimate goal of this research is to compare residual shear strength parameter with the broad range of soil samples from diverse landslide location to prepare a database for LS rapid simulation, and also hope to perform LS rapid analysis for the 4 studies location using obtained residual shear strength parameter to predict the runout path. These are the references I used. Thank you.
Thank you, Ms. Simalsha, for this interesting presentation. So, since we are running out of time, so we'll quickly move to the next presentation, that is enhancing the reliability of half-cell corrosion detection in aging concrete structures. So, it is done by Ms. EPT Patirana. Over to you.
Good afternoon, everyone. The topic of my research is enhancing the reliability of half-cell corrosion detection in aging concrete structures. Contents of my presentation. First, we move on to introduction. The history of concrete as a building material dates back to at least 5600 BC. The modern reinforced concrete invented in 1849. At present, concrete plays a major role in global built environment, and it is the most versatile building material in the world. The demand for concrete is rising rapidly due to its exceptional compressive strength and durability characteristics. Do all RC structures withstand their expected service life? No. Due to several reasons, concrete undergo different degradations. The most common concrete degradation mechanism is embedded rebar corrosion. Corrosion repairs in RC structures incur substantial financial burdens to the country, and it diminishes service life of structures. Research background. Signs of corrosion, rust stain lines, cover cracking, or concrete spalling become visible when it is reached to advanced stages. Therefore, early detection of corrosion is vital. Many advanced techniques are introduced to detect the onset of corrosion, namely sensor systems, but sensor installation for existing structures is really challenging. The most promising and the simple method for corrosion detection is the open circuit potential method called half-cell potential testing. It measures the potential difference between embedded rebar and the surface electrode position on the concrete by using high impedance voltmeter. Here I show you how we conduct this testing, ensuring electrical continuation between embedded rebar in concrete. There are more influencing factors for half-cell potential testing. There is interpretation guidance given in the ASTM standard, but when our potential values in between minus 200 millivolt and minus 350 millivolt, it interpreted as corrosion is uncertain condition, and monitoring individual test parameter electrical current is inadequate for reliable corrosion diagnosis. So subsequent to the corrosion initiation, most of chemical and physical parameters of concrete and the steel concrete interface are changing. When we examine in those parameters, we can enhance the reliability of corrosion detection techniques. The objective was to enhance the reliability of electrochemical corrosion detection technique, half-cell potential testing, by analyzing corrosion-related building investigation data from inland and coastal regions. This study consisted field data of real RC structures apart from the laboratory control conditions. When we move on to the methodology, first we conduct visual survey and select 35 numbers of typical RC columns located in school building at different exposure settings. Then rebar arrangements, cover readings were taken by using cover meter, and the moisture status was measured using aquameter. Then concrete powdered collected by drilling to determine the chloride concentration and spread the phenolphthalein as a pH indicator to determine carbonation depth. Then we conduct half-cell potential testing and surface resistivity testing. After that, corrosion-related parameter results with HCP readings were examined and exposed the related rebar points. Then we tabulate our test results and categorize those results as per the STMC 876 standard. Finally, we recommend required test parameters need to conduct simultaneous to the HCP testing. Here, electrochemical, chemical parameters, average cover measurement, and moisture status of 35 numbers of columns are tabulated in these two tables. Then we move on to the results analysis. The obtained half-cell readings were categorized into three main categories as per the STMC 876 standard. And then when considering level of chloride concentration near this category 3, we subdivide into another two. So firstly, we consider about category 1. Here, cover satisfied, carbonation is insignificant, and resistivity indicate low risk of corrosion. The low chloride concentration, those parameters reveal that no signs of corrosion. Here I show you related color plots of half-cell potential testing which indicate 90% probability of no rebar corrosion. Then we expose the rebar point. Real scenario was no signs of corrosion initiation. Then our corrosion-related test parameters, half-cell testing, and the actual conditions were compatible. Then we move on to the category 2. Here cover insufficient and carbonation not significant. Resistivity indicate high risk of corrosion and high chloride concentration. Then related color plots of half-cell potential testing indicate that 90% probability of rebar corrosion, and we expose the rebar point, we observe that signs of corrosion activations. When we move on to the category 3, in category 3A, average cover was 22 millimeter, which is not satisfied, and the carbonation is more than cover concrete, and the resistivity is negligible, and chloride concentration is lower. This heavy carbonation indicates susceptibility of rebar corrosion. Then we move on to the category 3B, same scenario, cover insufficient, and also carbonation is beyond the embedded rebar, and also chloride concentration is higher. That higher chloride concentration prone to corrosion activation. Here I show you obtained color plots of the half-cell potential testing, which is denote that corrosion is uncertain. Then we expose the rebar points. We realized that there are signs of corrosion initiation in embedded rebar points in both categories 3A and 3B. In both scenarios, we identified that carbonation is beyond embedded rebar. So it means that alkalinity of concrete reduced to pH 9 or below. Electrical conduction through concrete need continuous pore network, then formation of this calcium carbonation, which means carbonation, calcium carbonate, pore clogging effect happen, and it induce resistive media. This obstructs the electrical continuation through concrete and reduces the reliability of half-cell potential results. HCP testing is not sufficient for accurate interpretation of corrosion kinetics in all scenarios, majorly for carbonated concrete. Related technical reports emphasize that HCP method need to be interpreted in the context of additional information. So in this case study, we use our building investigation data and validate this concept, which is to diagnose corrosion activity in 3A, 3B types of carbonated concrete. It is essential to conduct chemical parameter testing, namely chloride levels, carbonations, and the cover measurements consequent to the HCP testing. Conclusion. Half-shell potential results of heavily carbonated aged concrete shall be misinterpreted by actual condition of embedded rebar due to the pore structure refinements. Subsequent to the half-cell potential testing, it is essential to inspect carbonated conditions, level of chloride concentration, and cover measurements of the moist column concrete. It is recommended an integrated test program consists of HCP testing, which associate with the corrosion-related chemical parameters to enhance the reliability of corrosion interpretations. as a way forward, need to conduct comprehensive study on physical, chemical, and mechanical parameters of concrete and rebar of age-corroded RC concrete to develop the corrosion detection technique. And also now we are introducing various kind of cement supplementary materials. It is needed to determine related critical chloride content, chloride ingress rate, and the carbonation of different binder types other than conventional values. Acknowledgements, key references. Thank you very much.
Thank you, Ms. Patirana, for this wonderful presentation. And yeah, I just realized that on the left of so we have the two presenters who won the awards in the NBRO Research Symposium. So feasibility study on the use of waste currency notes for value-added products. So the presentation will be delivered by Mr. Virasena. So he's a scientist from Building Material Research and Testing Division.
Good afternoon, everyone. I'm Chirajjayanaka Virasena. I'm going to present my research topic on feasibility study on the use of waste currency notes for value-added products. This is the content of my presentation. Under the introduction part, actually we are eliminating a large amount of waste currency notes per month. So mainly these currency notes are set into small briquettes, and mainly we are burning them using incinerators, and also we are using them for landfilling applications. If we are burning them, there are some hazardous gases can be evaporated to the environment. It will cause to the air pollution. When we are use them for landfilling application, there are some hazardous gases, hazardous chemicals can be accumulated the environment. So effective disposal is very important for us. These are the shredded currency briquettes. Central Bank of Sri Lanka eliminates around 15 tons of waste currency notes per month. Under the literature review, there are some countries made value-added product using currency waste. India and Egypt made handmade papers using currency waste, and some multinational researchers made pulp using currency notes. So the Denmark researchers found some hazardous chemicals incorporated with these currency notes. According to the literatures, we found the main component of the waste currency is cellulosic fiber. Other than that, polypropylene, lignin, hemicellulose, and some metal ions can incorporated with these waste currency notes. Some of them are heavy metals. Because of the cellulosic fiber, we can use them for making plywood boards, soft boards, handmade papers, and decorative items. So our main objective is developing a value-added product using shredded currency waste in Sri Lanka. So under the task breakdown, we need to find the suitability of currency waste for building applications, and also we need to determine the product properties and compare the properties with existing market product. Then we need to study the properties to meet the international standards. Then we need to convert the currency waste into eco-friendly product. So let's move on to the methodology. Under the stage 1, we need to select the raw materials. The main raw material is shredded currency briquettes. The other one is bonding agent. Actually, we were trying so many binding agents, such as cement, polyvinyl acetate, urea formaldehyde, and LDPE. Because of some drawbacks, such as bad odor occur during the production process and uneven distribution of the particles. So now we are using resin and hardener to make our product. Under the stage 2, we need to cast our product. So first we need to mix and compressing. This is the production procedure. First we need to mix the raw materials, then lay it into the mold, and we need to compress it using universal testing machine. And this is the mold, this is the production procedure. So under the stage 3, we need to do the mass scale production. Before that, we need to evaluate the properties. This is our end product. Actually, we cast this type of end product with 2 different thicknesses and 3 different mixed proportions. Under the detailed findings, we need to evaluate the properties such as noise reduction coefficient, thermal conductivity, density, and modulus of rupture according to the standard test methods. So the first one is noise reduction coefficient. Actually, in Sri Lanka, we have no proper method to determine the noise reduction coefficient, so that we fabricated an apparatus using acrylic sheets. So we gave different frequency using frequency generator and also the Bluetooth speaker. Then we measure the noise level using noise meter. According to the test results, mixed proportion 1 shows the high noise reduction coefficient value. So it indicates the excellent sound absorption. So the second one is thermal conductivity. This is the thermal conductivity apparatus. This is known as guarded hot plate method. Actually, we measure the temperature in different levels. So after that, we graph the temperature variation. According to the test results, mixed proportion 1 shows the lowest thermal conductivity value. It indicates it acts as a good thermal insulator. So under the density, the third one is the density. We measure the dry bulk density. Actually, the density is around 900 kilograms per square meter. So kilograms per cubic meter. So it flows on the water. So the fourth one is modulus of rupture. Actually, we fabricated the test mold according to the standard test method, and we measure the deformation using dial gauges. So according to the test results, mixed proportion 1 shows the high modulus of rupture value. It's around 16 megapascal. Under the test results summary, all test results are satisfied according to the test standards. So in near future, we are planning to evaluate the properties further, such as fire resistivity, moisture absorption and durability, and we are hoping to compare the properties with existing market product, and also we need to design the large-scale production procedures. When we consider about the material cost, it's around 2,900. So under the conclusion part, because of the high noise reduction coefficient value, it indicates the excellent sound absorber, so we can use them for acoustic application and also ceiling and partitions. Because of the low thermal conductivity value, it falls within the thermal insulator category, so we can use them for heat insulation in buildings. According to the density results, it falls within the high density particle board category, so it ensures the good mechanical strength and also durability. And according to the modulus of rupture data, it also falls within the high density particle board category. So it has high load bearing capacity, and also we can use them as a decorative items. These are the end product, and these are the reference. And thank you very much.
Thank you very much, Mr. Virasena. So, thanks for waiting. And yeah, we'll move to the next presentation. That is effectiveness of concrete jacketing to enhance load carrying capacity of building. A case study for the Sri Lankan building code. The presenter is Ms. H.A. Pathirana, engineer from Structural Engineering Research and Project Management Division of NBRO.
Good afternoon to everyone. I'm Hashini Pathirana. Let me introduce our research study, Effectiveness of Concrete Jacketing to Enhance Load Carrying Capacity of Buildings. This is a case study for the upcoming Sri Lankan building code. This is a quick overview for the today's presentation. We will start by exploring the background or the foundation of our study. Then we will uncover its aims and objectives, followed by the methodology. Then we will dive into the results and discussion, presenting the key insights. Then we'll arrive at our destination with conclusions and future work. Buildings rise, but rules ignored. Designs are changed, safety flawed. Flaws are added without due test. Strength is lost, yet lives are spent. This is the sad truth we experience, especially in Colombo, the thriving capital city of Sri Lanka. Let me bring you some examples as proof to this statement. In this figure, you can see a 4-storied building. Although it is not meant to be a 4-storied building, it was originally a 2-storied building. This is a 7-storied building. The original design details were in well compliance with the design codes and standards. But unfortunately, these design details were not converted into reality as it is. Again, you can see a 7-storied building. This building is under enormous structural distress. There were cantilever beams supposed to cater loads from about 6 upper floors. All were cracked, and at somewhere in the 2nd floor level of this building, there were beams spanning a distance of about 12 meters with inadequate depth to span such a long distance. And also these beams were supposed to support some floating columns which carry the loads of upper floors. And during the time of investigation, we could see some silent cracks in the mid-spans of these beams. But under normal operation conditions, these beams are hidden by the ceiling, so nobody knows. Such faulty construction in the country is mainly because we do not have a legal mandate in the country to govern its construction industry. Buvelikada building collapse and Vellavatta building collapse are 2 such prime incidents which clearly showcased how non-adherence to building design codes and standards lead to building failures. On the other hand, although the country is blessed with its natural geographical location, it's vulnerable to natural hazards. Floods and landslides are more common with relatively low impact. Cyclones and earthquakes are very rare, but their impact severity is very high. These kind of natural disasters can bring down these defective structures very easily. So, before the history repeats, the government of Sri Lanka has initiated an effort to develop a national building code for Sri Lanka and mandated the National Building Research Organization, Urban Development Authority and the Construction Industry Development Authority to ensure that resilience is embedded in this new building code. By the time this National Building Code is implemented in Sri Lanka, let's say 2 to 3 years from now, the existing building stock in the country will probably represent a mix of both code-compliant and non-code-compliant buildings. So this new building code is not only responsible for governing the new construction, it also has a responsibility towards the existing built environment in the country. So we have proposed a separate dedicated chapter called Existing Structures into this new building code in order to act as the legal mandate to the existing built environment. And most importantly, this existing structures main chapter should be well equipped with the appropriate retrofitting measures to safeguard the resilience of the built environment. So in this research study, we have selected one such retrofitting technique called concrete jacketing. In simple terms, concrete jacketing is a second skin for existing defective structures where the existing concrete elements are encased in a fresh layer of concrete and reinforcement. So here our aim is to evaluate the effectiveness of concrete jacketing to use as a retrofitting technique to enhance the load carrying capacity of buildings. In order to achieve this aim, we have set 3 objectives. The first one, to assess the performance of concrete jacketing by comparing the pre and post retrofitting performance. The second one, to propose practical recommendations to include this as a standardized retrofitting method in the Sri Lankan Building Code. And third one, to highlight considerations like structural efficiency, cost effectiveness, and ease of implementation in a local context. Moving into the methodology, it's a 5-step approach. Let's go one by one. The first step is the structural analysis and design check for an existing building. This is the building we selected. Upon the request from the building owner, we went on a site visit. At that time, the building was not occupied. We were provided with the original design drawings. Something rarely happens when we do structural investigations for existing buildings, but we wanted to confirm whether these details are there in the actual building. So we conducted building material testing to identify the actual section sizes, reinforcements, and strength parameters. By utilizing these results, the existing sizes and the existing loadings, we conducted computer modeling, structural analysis, and structural design checks per the Euro norms. This is a snapshot of the building we created. It's a 7-storied building with a basement with nearly rectangular plan view resting on a raft foundation. You can see an elevation view of the building also. These structural design checks were conducted for each and every element of this building. But due to the time constraints, I will be only showing you the results for the critically loaded column and the critically loaded beam. Here you can see the comparison of the demand on this critically loaded column against its capacity. The green color code represents the demand and the blue color code represents the capacity. As you can see here, the demand is always lesser than the capacity, but at certain instances you can see these demands are about to exceed the capacity. This comparison is only valid when these member forces act on this critically loaded column separately, but when these act all together on this column, these capacities will be reduced. So according to our findings, this critical column cannot carry the existing loads at both serviceability limit state and the ultimate limit state. This clearly showcases a discrepancy between the design theory and the actual conditions. Thankful to the design safety factors and the higher design loads we consider in the design stage, this building is there without causing any kind of disaster. Similarly, for the critically loaded column, you can see the demands are lesser than the capacities, but at certain instances, these demands are about to exceed the capacities. Anyway, this existing beam can support the current loads at both serviceability limit state and the ultimate limit state. Then moving into the second main step, the retrofitting proposal. It is important to note that this building is not occupied at the moment. Once it is occupied, it will incur more and more loads onto this building. You can see the percentage increment of loads on this critically loaded column. And here we have done a comparison between the all demand against the existing capacities. You can clearly see that the demands are exceeding the capacities. So we need retrofitting. This is the section and the reinforcement details we propose for the column retrofitting. Then moving into the critically loaded column, critically loaded beam, you can see the percentage increments in the loads, and we have compared the all demand against the existing capacity. The demands are going beyond the capacity. So this beam also requires retrofitting, and this is the section and the reinforcement details we propose for the beam retrofitting. Then moving into the third step, that is the structural analysis of the retrofitted building. By utilizing the assumed section sizes and the reinforcement arrangements, we again conducted computer modeling, structural analysis, and design checks per the Euro norms for our new building. Then moving into the fourth main step, this is the element level design check. First, the critically loaded column. You can see the improvement in the capacity of this column once it is retrofitted. Here we have compared the demand against the capacities, the old demand against the new capacities. So you can see the demands are lesser than the capacities. According to our findings, this column can carry the loads at the serviceability limit state, but not at the ultimate limit state. So this needs further revisions. Then for the critically loaded beam, you can see the capacity improvements in this beam when it is retrofitted. And in this comparison, you can see the demands are higher than the capacities when it comes to the hogging bending moment. And for the cases of sagging bending moment and the shear force, the demands are lesser than the capacities. So structural concrete jacketing is identified as a viable method to improve the sagging bending moment capacity as well as the shear force capacity of the beam, but not the hogging bending moment capacity of the beam. Then moving into another element level analysis, that is to check serviceability criteria or the deflection. A finite element model of the defective beam and the retrofitted beam were created in a finite element modeling software, and the load displacement curves were derived. In this graph, you can see the one in orange color, it represents the defective beam, and the one in green color represents the retrofitted beam. You can see that there is a drastical improvement in the ultimate capacity points where the beam transits from linear range to non-linear range. You can see two horizontal lines running from bottom to top. This represents the existing loads at the serviceability limit state and the existing loads at the ultimate limit state. At somewhere in between, this curve transits to non-linear range. So this beam can safely carry the existing loads at the serviceability limit state. Again, you can see another two horizontal lines from bottom to top. This represents the all loads at the serviceability limit state and the ultimate limit state. You can see the ultimate capacity point is above the all loads at ultimate limit state. So this beam can safely carry, the retrofitted beam can safely carry the all loads at the ultimate limit state without causing any serviceability issue. Then moving into the last step, the system level design check. A model analysis was conducted here. The green color code represents the defective building and the blue color code represents the retrofitted building. We could see a change in the dominant mode direction, probably due to the change in the distribution of mass and stiffness with retrofitting. And also there is an increase in the natural frequencies, and it indicates that the stiffness and the overall robustness of the building has been increased, thus indicating that the building's ability to resist deformation is also increased. And also we can see an improvement in the fundamental mode's mass participation ratio in only one direction but not in other direction. This emphasizes that retrofitting has altered the structure's dynamic response, leading to higher complex modes with larger internal forces and complex deflections. Finally, to conclude, this study investigated the effectiveness of concrete jacketing to strengthen defective buildings. The element level capacity analysis clearly showcased that this defective building cannot support the current loads, to a certain extent, but it cannot carry the anticipated future loads. The retrofitted building can support the loads at both serviceability and ultimate limit state, except for the hogging bending moment capacity of the critical loaded beam we considered in this study. This retrofitting proposal should be further optimized to minimize the overstrength, material wastage, and construction cost. The global structural analysis of these buildings suggested that we need to refine this retrofitting proposal to avoid complex displacements of the building. And before we integrate this as a retrofitting method in the Sri Lankan building code, further research needs to be conducted. These are some future work, full-scale testing and case studies need to be conducted. And also the resilience of defective and retrofitted buildings should be evaluated for extreme wind and earthquake loading, and also some other retrofitting methods should be investigated. These are the references I used. I acknowledge with gratitude the National Building Research Organization for providing the necessary facilities, as well as my research supervisors for providing invaluable mentorship for the ongoing research work. Thank you.
Thank you, Ms. Patrana. So since we are having a tight schedule, so I can allow one question for each presenter. I believe, so since we had a session, so one with geotechnical engineering, one with material engineering, another one for structural engineering, and also one for, again, building materials. So,
yeah, this is, I'm Viraj. This is for Ms. Patirana. Thank you for your elaborated presentation. But I just want to verify that whether your study is above the ground level only. Am I correct? A structure above the ground level. Or are you considered even the below the ground level? Any verification for the building loads after your proposal? No, you're retrofitting always above the ground level structure,
I considered only the superstructure of the building.
Superstructure, but at the same time, once you added the loads, are you going to reassess the condition for the foundation level?
Yes, sir, we need to reassess it.
And what is the mechanism you added for this one? So you're confirmed that your foundation is okay.
No.
That assumption is there.
No, the substructure is a raft foundation. The thickness of the raft foundation is found to be not adequate. So we proposed an overlay on top of the existing raft foundation.
All right. Okay. Thank you.
This is also related to Engineer Patirana. Since we as responders, because during the collapse structures, because the structural engineering is so vital, and if anything happened like Vallavatta, so Disaster Management Center as a responders when implementing search and rescue operation, so we have to know about the undersurface and surface above surface, because through the urbanizations, metropolitan cities, skyscrapers, it creates different kind of a hazard kind of. It's a new hazard because as per the Act, we have only 21 hazard. So now we are going to include our National Emergency Operation Plans also this collapse structure kind of a hazard. So if you have these structures, if you identify now, you show few structures, because if anything goes wrong, we need to have some kind of a capacity. There are different entries for search and rescuers, like horizontal entries, vertical entries, and we do not have such equipments if anyone to rescue under the debris, like you need hydraulic cutters, you need different hydraulic leverage kind of system, different systems we need. So if you identify those structures your foundings, please share with us. Then we always on anticipated action plan, if it's early action, whatever the early warning kind of a thing, and they can do some contingencies. If you share with us, so vital. Thank you.
Okay, sir, we will do.
Any more questions? So, yeah, I have one question for Mr. Virasena. So, have you applied for a patent or something?
Yes, of course. We are processing that patent process. So actually we can't reveal everything in here. So I mentioned only mixed proportion 1, 2, and 3. So like that, we can't reveal everything this time.
And
okay, I also asking Mr. Virasena, you have done your study as a solution for the disposal of these things, and you said that there are some metals or heavy metals are added to the environment due to this disposal. So once your production, anyway we have to dispose. So do you think about that also? In some day it has to be disposed, then all these things are coming to the environment again. Do you think about that? Or
Actually, sir, we can reuse it when it disposed to the environment, or when it like cracks. If it propagate cracks, we can use it again to make this type of product with using our bonding agent. Yes, yes, we can reuse it.
And yeah, I'll have one question for, again, another Ms. Patirana. So the question is like, how all the structures that you have used as your samples?
For our study, we used 30 years old. Just approximately 30 years, because normally most of structures we don't have details, like structural details and other things. Then normally we have approximately 30 years old buildings taken for the study.
How long does it take for the carbonation to process like this in, like, if you have any idea about that? So is the general norm that you go for a 30 years old building, or?
Here we use what we have, the investigated building details, but it's generally, it's proportional to the time route. Normally it's the norm, but it depends on the concrete properties. When it is in low quality properties like loose compaction and mixed details and not recommended values, specified values, then carbonate more, very rapid carbonation we observe. It depends on the quality of concrete.
Thank you very much. And one question to Ms. Imalsha. So could you explain, like, what are the limitations or difficulties that you have experienced while doing the ring shear testing?
The main problem encountered during the ring shear testing was saturation procedure for high fine content soil was time consuming because it's low permeability. And then for low normal stresses, test results are less accurate.
Okay, thank you very much for this a very interesting presentation. So we had 4 presentations in this session. So one is about from the ring shear apparatus. The another is about using half-cell corrosion detection to test the aging of concrete structures. The other one, how to apply the concrete jacketing to enhance the carrying capacity of buildings. And finally, how to use the waste currency notes for a value-added product. So I believe this session covers a vast area of very informative details, and I wish you all the very best for your future endeavors. Thank you very much for everyone.
We thank you for our session chair, Engineer Dr. Sanchita Jayakodi, for his exceptional leadership and guidance given for this session. And our sincere appreciation also goes to our presenters and their insightful outputs.
As we come to the conclusion of this enlightening technical session, we would like to take a moment to recognize and appreciate the contributions of our esteemed presenters. So, to honor their participation, we now invite our session chair, Engineer Dr. Sanchita Jayakodi, to present the certificates to the presenters. Presenters, as your names are called, please come forward to accept your certificates. Ms. W.C.M. Imalsha, Ms. E.P.T. Pathirana, Ms. H.A. Pathirana, Mr. O.V. D.C.J. Veerasena.
And Dr. Sanchita Jayakodi, please remain for a moment. Before we conclude, Dr. Sanchita Jayakodi, and now I would like to invite Professor Balasurya, Head Department of Geology and Director, Postgraduate Institute of Science, Peradeniya, to present the token of appreciation to Dr. Sanchita Jayakodi.
With that, we conclude the second technical session. We appreciate your participation and look forward to more engaging discussions in the upcoming session.
Now we are moving on to the last technical session, which falls under the digital innovations in early warning and risk communication for early actions.
Before we commence with the presentations, it's my honor to introduce our esteemed session chair, Planner Diane Munasinghe, who will be guiding us through the third technical session. Planner Diane Munasinghe serves as a senior scientist in the Human Settlements Planning and Training Division at NBRO. His academic journey includes a Bachelor of Science degree in Town and Country Planning from the University of Moratuwa, Sri Lanka, a master's degree in thermal and environmental performance of precast buildings from the University of Moratuwa, Sri Lanka, and reading for doctorate in disaster risk propagation at the University of Salford, UK. Mr. Munasinghe specialized in the areas of disaster risk analysis, modeling and planning, building performance simulations, GIS, remote sensing and data mining studies, and landslide resilient settlement planning. Further, his expertise also extends to landslide risk reduction, flood and landslide runout modeling, thermal and environmental performance, MATLAB, SPSS data mining, cost-benefit analysis and socio-economic analysis, drone mapping, and research studies. Furthermore, he contributes to academia by teaching programming for GIS in the Master of Science in Geoinformatics program at the University of Colombo.
So now I kindly invite our esteemed session chair, Planner Diane Munasinghe, to the head table.
So this is the last session of 14th Annual Research Symposium. The session topic is digital innovation in early warning and risk communication for early actions. So there are main 4 presenters. I would like to invite all 4 presenters seated into the front table. Mr. Ruhunuge and Dr. Vasantha Senadira and Pasindu Vikramasinghe and Dr. Imaya Aryaratna. So without taking much time, we can go to the first presenter. Is Mr. Ruhunuge. He's studying on prediction of air pollution episode, a case study for Colombo urban areas in Sri Lanka.
Good evening, ladies and gentlemen. So I'm Ruan Ruhunuge from the Environment Division. The topic of my presentation is prediction of air pollution episode, case study for the Colombo urban area. So let's move on to the introduction. What is the air pollution? As per the WHO definition, air pollution is contamination of indoor or outdoor environment by any chemical, physical or biological agent that modify the natural characteristic of atmosphere. That is the definition. So when we consider about the context of Sri Lanka, the PM 2.5 is the most critical pollutant in Sri Lanka. So we have previous experience. We have faced several cases regarding this high polluted air quality due to the PM 2.5. So when you consider the PM 2.5, that is directly caused to our health effects. Then what we can do to prevent these exposure levels? We need to do some kind of predictions. Otherwise, we have to identify some kind of cases in the future. So in this case, we are going to predict an air pollution episode. Air pollution episode is a period of time when air pollution levels are higher than the normal levels. It's directly related with the meteorological parameters and also some kind of emissions. These are the direct correlations. We have faced, since last few decades, we have faced several cases. These are the few air pollution episodes. That is a very popular case, the Bhopal episode. We all know that case due to the emission of gas leakages from the fertilizer synthesis factory. Why we need to predict an air episode? First one is to assist citizens to take proactive measures, to warn public exposure to the poor air quality, to assist the government to controlling emission through the legislations, to aware and act voluntarily reduce this emission. These are the 4 main things Except these things, we have lot of importance factors when we predicting the air pollution episode. Within this study, the main objective is development of methodology for the confirmation, prediction of air pollution episode due to particulate matter. In here, we have selected particulate matter because that is the most dominant air pollutant in Sri Lanka nowadays. This is the methodology what we have followed to the prediction, the air quality episodes. We have gone through the several literatures and we found different kind of prediction method. There are plenty of methods available. In here, we have listed here several methods. In here, the persistent forecast, it's the simplest forecasting method. What we do is, we look today, we predict tomorrow. That is very simplest. And also, we like use climatology methods and the criteria method. Based on the data available and what are the observation we have, based on that, we predict our next few days. During the study, we collected PM 2.5 data for the 3 years for the Colombo 7 area. And after that, we do some statistical analysis to forecast the next few days about the PM 2.5. These are the decision criteria. Our main target pollutant is PM 2.5. This PM 2.5 value can be directly impact from these parameters. These are meteorological parameters. Based on these parameters, this PM 2.5 value can be changed. These are the variables listed in this table, and the impact factor for the PM 2.5 variation is listed in the right-hand side of the table. These data are directly obtained from the weather forecastings. Now move on to the research and discussion. These are the data, past data, Colombo 7 area, 1 month period. And in here, these are the how these PM 2.5 values are changes in between 1 month period. After the 1 month period, we forecast these PM 2.5 values. In here for the forecasting, there is no need to use of sophisticated or some kind of numerical modeling. We can use any kind of statistical software, including Excel and also MATLAB, Minitab, anything. In here, we can use different kind of extrapolation technique, moving average extrapolation, and spine extrapolation. Based on this extrapolation, we take next PM 2.5 level after the 30th day. We have to have some kind of threshold value when we predict, when we forecast about the air quality episode. Our threshold value is 50 milligram per cubic meter. That is the National Ambient Air Quality Standard for 24 hours for the PM 2.5. This is our threshold. Within, we are always look this threshold and we try to predict it may be higher or lower. That is our task. This is the first influence factor for the PM 2.5 variation. As you can see, that the first influence factor is mixing height. According to this graph, if there is any temperature inversion in the atmosphere, because of that, it inhibits vertical mixing and it prevents dispersion of pollutants, and also it leads to poor air quality. That is like a linkage. If the temperature inversion is present, that means it lowers the mixing height. That means it leads to unhealthy episode. That is the case. These are the results plot in between PM 2.5 concentration and also the wind speed. You can see in this graph, almost 85% of the episodes are recorded in between 4.4 meters per second. This is the, you can see the 50 threshold value. As I mentioned earlier, this is the threshold. We are looking beyond that. The wind direction. Similarly, in the first case, almost 60% are in between 0 to, northeast direction. Beyond that, we have some cases, but the dispersion and the density of these cases are very low. That's why we selected, this is the high density zone. The most, this kind of graph shows the higher probability value of occurrence of this kind of episode. That means if the wind direction is northeast, that is the favorable for unhealthy episode. The influence factor 4, ambient temperature, beyond the 27.5 centigrade, it almost 98% of data points are observed beyond the 27.5. That means it's favorable for the unhealthy episode. Similarly, cloud cover, if it beyond the 4.2 octas, it's favorable for the unhealthy episode. That is this one is the most critical thing. This is the transbound incoming and also local carryovers. In this influence factor calculation, we use single particle Lagrangian integrated trajectory model. This model has ability to identify where the major sources and how it transforms to our desired location, and to how this PEM 2.5 can vary in between these lines. In here example, we set threshold value 50 microgram cubic meter, and we observe after the modeling, we identify this kind of trajectory from the Indian continent, and then we can set, like if we get 50 microgram per liter, there is a certain contribution from this trajectory. That means we can ensure that within next day, we will get more than 50 microgram per cubic meter because of this wind path. That means it's a backward trajectory hotspots favorable for unhealthy episode. This is the conclusion. My episode is PM 2.5 greater than 50 microgram per cubic meter. If these parameters, I mentioned one by one earlier, if these parameters within the exceed limit or threshold values, it verified that there is significant probability that episode will occur. In here, we clearly mentioned our episode is greater than 50 microgram per cubic meter. By using these parameters, we can confirm, or other than we can say it like with a higher probability value, this kind of event can be happen in future. Thank you very much.
Thank you, Runuki. So still this work we are talking about the air, and the second presentation also we are talking about the air. So second presentation about, it's not air like it's atmosphere. Second presentation about evaluation of existing empirical rainfall threshold with heavy rainfall triggering landslide occurrence to support landslide early warning process. So it's over to Dr. Vasantha Senadira. He's a senior scientist at Landslide Research and Risk Management Division of NBRO.
Good afternoon, everyone. I am Vasantha Senadira, senior scientist from NBRO. Our title is Evaluation of Existing Empirical Threshold, Rainfall Threshold for Landslide Early Warnings. These are the contents. Next, move on to the introduction. Why we need early warning system? We need early warning system because if we live in dangerous area or vulnerable to any disasters, early warning system is essential, not only landslide, but also disaster like floods, tsunami, cyclone, earthquakes, etc. In NBRO, in Sri Lanka, National Building Research Organization has identified 14 landslide districts in Sri Lanka. The primary triggering for landslide is rainfall. Sri Lanka experiences two main monsoon and the two intermonsoon periods. Northeast monsoon, December to February. First intermonsoon, March to April. Southwest monsoon, May to September. Second intermonsoon, October to November. This is the empirical threshold values. As the designated authority, the National Building Research Organization issued landslide early warning alerts based on the real-time cumulative rainfall for 40 landslide as prone district. The warning threshold have been determined using limited number of recorded landslide incidents and the associated cumulative rainfall analyzed by the expert in NBRO. However, these generalized threshold values applied to entire district do not account for site-specific variations. These are the warning levels. Level 1 watch. Threshold limit is 75 millimeter per day. Color code is yellow. Warning level 2 alert. Threshold limit is 100 per day. Color code is amber. Level 3 evacuation. Threshold limit is 150 per day or 75 millimeter per hour. Color code is red. This is our research problem. The current landslide early warning system in Sri Lanka, which is based on the generalized 24-hour daily cumulative rainfall amount, no consideration of long-term seasonal impact, which is needed to effectively address the landslide events. Hence, the study focuses on seasonal influence considering poor monsoon that would help to effectively address the landslide events. Then we move on to the objectives. This is the primary objective, to enhance the accuracy of rainfall threshold for ensuring landslide early warning in Sri Lanka. To achieve this objective, we talk about the four major tasks. Task 1 is analyze historical warning and rainfall data. Task 2 is reconstruct critical rainfall events and trigger conditions. Task 3 is evaluate current threshold against reconstructed data. And the final one is determine optimal timing for warning issuance. Next, move research area. This is the research area. The 25 incidents spreading over the 11 districts. We have studied the 25 incidents to obtain the results. These are the districts. Here. Then come to the methodology. There are three process inputs in the process. The first one is input, second one is data analysis, and third one is justification using the statistical observations. In inputs, when consider the inputs, there are two major types: real-time rainfall archives and landslide incidents database. This is the tool for calculation thresholds for rainfall introduced landslide using control T tools. This is the flow. When come to the results, the task 1 analysis historical warning and rainfall data. This is in Matale district. There is a landslide at Atangwala. The y-axis indicates the cumulative rainfall, and the x-axis indicates the date and time of the incident. Same analysis done for the Kandy district in Varadivala and Karagala. The result task for analysis, this table indicates the comparison of issued landslide early warning and the real time rainfall. In this table, the first column indicates the hits. Hits means we have issued the early warning according to the rain gauge values. The misses means we have issued the early warning, but rain gauge is inactive. The false alarms means the rain gauge is active and we have issued the early warning, but not the correct one, the correct level. This is the bias accuracy calculation for the data sample. The bias accuracy is 12%. The results for the task 2 reconstructed critical rainfall events and trigger condition. This is the flow of the calculation of thresholds for rain induced landslide tool, Control T. This map indicates the landslide incidents buffered using multiple rings of 5, 10, 15 kilometers to identify the nearby rain gauge. This table indicates the selection of the most effective rain gauge to select the landslide incidents. This graph indicates the time series plots for 30 minutes difference and the cumulative rainfall. The left y-axis indicates the 30 minutes rainfall difference and the right y-axis indicates the cumulative rainfall during the season, and the x-axis indicates the date and time of the incidents. This table obtained from the calculation of the rainfall incidents and the nearby rain gauge. This is the hypothetical theoretical used for the analysis. This table indicates the obtained results. We have done this analysis for the other 25 sites also. This is the final table. Our existing warning system has watch, alert and evacuation. Limit is 75, 100 and 150. The reconstructed threshold values, there are two types, alert and evacuation. Values are landslide for 850 millimeter, cutting failures are 650. And the in the evacuation, landslide measures is 1000 millimeter and the cutting failure for 750. This is the conclusion. Seasonal consideration. Seasonal rainfall impacts, including monsoonal pattern, should guide early warnings. Seasonal threshold introduce 854 alerts, 1000 millimeter for evacuation. The collaborative system combines seasonal and short-term cumulative threshold is essential for a more effective early warning system. These are the future recommendations. And finally, this study shows promise in fine-tuning thresholds for progressively increase the accuracy of landslide early warnings by reducing false alarms and misses. This is the references. Thank you.
So now we are moving to ground, like how we assess the landslides on the ground. So I would like to call third presenter. He's working on an application of mask RCNN in mapping cut slopes using LiDAR digital terrain model, Mr. Pasindu Wickramasinghe. He's a scientist at Human Settlement Planning and Training Division of NBRO.
Good evening, everyone. Today we are going to present about this research in an application of mask RCNN in mapping cut slope using LiDAR digital terrain model. So our research group mainly consists with Selvaraj Jayaprakash, Nimesha Kalanga, Dayan Munasinghe, and myself. So when it comes to the landslide types in Sri Lanka, there are different types of landslide types, such as landslide and debris flows, slope failures, cutting failures, rock falls, and others such as retaining wall failures, subsidence, and riverbank failures. So currently, cutting failures are one of the major landslide type we observed, which create significant damages to humans as well as economic damages. So in 2024, we have recorded 61% of landslide incidents or cutting failures, And out of total 6 deaths recorded in 2024, 5 were recorded because of the cutting failures. And also, according to the risk profile database, we have observed that 52% of buildings have cut slopes behind the structure. And at the same time, from that 52%, 85% of cut slopes are unprotected cuts. And at the same time, based on the risk profile database, we identified that 67% of houses were constructed without having a professional support. So here this figure shows that the Vatuli at the cutting failure, which caused for 1 death and 3 injuries. So currently, with the direct field investigations, we identified cutting failures, and also, but the issue with that is they are time consuming and resource consuming, and as well as we can do spatial assessments to identify cut slopes, but they also face challenges because of the lack of spatial data resolution, and also with the haphazard constructions and with the loops in planning applications, we can observe that the number of cut slopes were increasing day by day. Therefore, there is a requirement for an iterative cut slope detection methodology in landslide-prone districts. So, an automated process to extract cut slopes to identify possible cutting failure locations there is a requirement. So, we did a literature survey and identify what are the several methods to investigate cut slopes. So most of them rely on the manual methods and can be caused to human error and also time consuming and resource consuming. But with the enhancement of the remote sensing applications and the enhancement of spatial data resolution, we could observe that basic machine learning models are used to detect cut slopes and using LiDAR digital terrain models. But after with the modern technology in convolutional neural network architectures, we can observe that object detection and image segmentation models such as UNet, SegNet, mask RCNN models are currently used to extract features from images as well as object detection. Based on the literature review, we identified that mask RCNN models outperform than other models in GIS-based image segmentation applications. So the research, there are 2 research questions in this research. First one is, what deep learning methods is more suitable for automating the cut slope extraction? And the next one is, how can CNN-based image segmentations techniques can be adapted to accurately extract cut slopes from LiDAR digital terrain models. So in this research, we have 2 main objectives. One is to develop a data-driven methodology for extracting cut slopes using an advanced CNN model and LiDAR digital terrain model, and to create a comprehensive automated cut slope inventory database. So when we move into the methodology of this research, it has 4 main steps. One is research question, the second one is preparing training data set, then third one is training the model, and the fourth one is the applications of the model. When we go into the research question, we have identified the research problem, and also we did a literature survey. And in the training data preparation, we have developed training chips around over 4,000 cut slopes chips in Nuwara and Badulla districts. And after that, we trained the model, and then in the applications, we have conducted pilot studies in Kegol, Nuwara and Badulla districts. So here we can observe that the training sample sites, and we did the training data sets developed in Badulla area, and the model tested in the Badulla area, and also the validation was conducted in Kegol, Nuwara and Badulla districts. So when we move into the mask RCNN architecture, first there is a backbone model. So in this model, it's ResNet 50 is work as the backbone of the model, and then it goes to the region proportional network where we can identify and detect objects, and then we move into the region of interest where we fine-tune the model. Basically, it's like it compared the training data set and the model prediction, and based on that, it fine-tuned the model. And the next one is fully convolutional nets, where it gives coordinates to the locations. So every model needs a training process. So the model was trained using these parameters as number of epochs around 20, batch size is 8, chip size is 128, and these were taken from the literature. So when we look at the training and validation loss during the model training period, we can observe that this model shows a precision of around 70% during the training period. And the model was tested in Haldunmulla DS area, and also during the testing period, we can observe that when it comes to the 19th and 20th epochs, the model, the loss is around 0.94, it's basically close to 0, and also the minimal disparity is around 0.02, so it shows that the reliability of this model during the testing period. And then we conduct the accuracy assessment of the model. So we did 2 accuracy assessments. First one is visual accuracy assessment and the statistical accuracy assessment. In the visual accuracy assessments, we have already developed we digitized the cut slope locations manually and compared the model's predicted cut slope. So there we could observe that the model demonstrated limited effectiveness in predicting comparatively small cut slopes, and also it's unable to identify cut slopes when most of the cut slopes are located more closely. And also in the statistical accuracy assessments, we did basically considering the true positive and true negative values of the model, and when the intersect over union around 60%, the model's precision is around 81%. So it highlights that this model can be used to identify and extract cut slopes using LiDAR digital terrain models. And also then we did the pilot studies in Badulla, Nuwara and Kegol. In Badulla, we did run the model for a 20 square kilometer area, and we identified around 1,347 cut slope locations, and in Nuwara we identified around 1,418 locations, and in Kegol we identified around 1,124 locations. So in the discussion part, so the mask RCNN model, this model shows that it has over 80% accuracy, and this model can be used to extract cut slope easily within few seconds. And also it could be observed that lower precision and recall values observed with the intersect over union threshold is higher. It shows that using this model we can't accurately identify the boundaries of the cut slopes. And also we could observe that the model demonstrates consistent performance across the different regional locations like Badulla, Kegol and Nuwara. And as the conclusion, in this research we have developed an automated cut slope extraction methodology, and with an accuracy of 81%, and in the intersect over union is around 60%. And we did pilot and testing in Badulla, Kegol and Nuwara districts. And so as the way forward, we can train this model with more data and get the higher precision values. And also using this, we can extract cut slopes and also identify the element at risk for future risk management purposes. Thank you.
Thank you, Pasindu. And now we are moving to the last presentation. This is about also how debris flow. This is about assessment of failure time predictions of landslide using pre and post mitigation monitoring data based on the relationship between velocity and acceleration. So it's by Dr. Imaya Ariratna. She's scientist of landslide research and risk management division of NBRO.
Good evening, everyone. I am Imaya Ariratna. Today's my presentation is failure time of landslide using monitoring data by velocity and acceleration relationship. This is the content of my presentation. Today's research study is mainly based on the prediction of failure time for rain-induced landslide by measured surface displacement data. Here, figure 1 shows the time variation of surface displacement. You can see 3 stages. At the end of the tertiary creep stage, failure occurs. Fukushima 1985 proposed the relationship between velocity and acceleration of surface displacement for tertiary creep stage as shown in the equation 1. Here V is velocity, T is corresponding time, divide dt means acceleration, A and alpha is the experimental constant. This relationship graphically could be represented as shown in the figure 2. Using this relationship, experimental constant A and alpha values could be derived from the intercept and the gradient of the relationship. Research question is how to utilize extensometers data for issuing landslide early warning. Accordingly, objectives are to study the relationship between the velocity and acceleration of surface displacement for slow-moving type landslides in Sri Lanka, to evaluate the mitigation effectiveness of Udamadura landslide using failure prediction method, to make the initial efforts to proposal to integrate its output into landslide early warning process. In the methodology, first let's look at the prediction of failure time. Mainly, most used methodology for predicting failure time is the inverse velocity. It is the relationship between inverse velocity and time as shown in equation 2 and the figure 3. You can see when inverse velocity approaches to 0 just before the failure. So using 2 sets of inverse velocity and time, we can derive the failure time. In this method, in every prediction, it's not gives precise predictions. So my study, I used the improved prediction method based on the relationship between velocity and acceleration method called VAA method. It's the rearrangement of equation 2, and for this prediction, we use the velocity and values of A and alpha and time. Speciality is the experimental constant A and alpha values were obtained the relationship between the velocity and accelerations as shown in the figure 4. Procedures for data processing. Here I am not going to explain so lengthy. I summarized the procedures of data processing. I use here data extraction method. In the data extraction method, what we did is pick up the data in different surface displacement interval. In this method, minimize the scatter. Here you can see in the figure 5, blue color is the measured surface displacement, green color is the extracted data greater than 1 millimeter. Here you can see in the blue color so many data, but when extracted, you can see only 2 values. When we consider data extraction method, mainly 2 factors were considered. First one is the scattering relationship between velocity and acceleration. Second one is the reproducibility of the measured data. These 2 factors assess using the determining factor values and RMC value. When the extraction surface displacement difference is increasing, scattering relationship is decreasing, but reproducibility of the data is decreasing. So to get the optimal displacement, we need lowest 1 minus f and lowest RMSC. Both values are not in same range, so normalized and finally optimal surface displacement intervals for data extraction give us at the summation of normalized lowest 1 minus f and lowest normalized RMSC. I used the study area, I used Udamadura landslide as the study area. This is the mitigation project carried out by NBRO and JICA. Currently, mitigation activities are completed. In the figure 6, you can see the location. It's in Nuwara district, and landslide hazard zonation map also there. It's in the high hazard zone. Figure 7 shows the Udamadura landslide and its features, and you can, I use the extensometers data for this analysis. These are some photographs of the some instabilities in that area. This Udamadura landslide first incidence occurred in 1957. After that, this area identified as a high hazard zone in 1995. After that, 2007, 2011, and 2015, some instability features were recorded. Let's move to the results. First, measured data. We categorize these data into mainly 3 stages as pre-mitigation, during mitigation, and post-mitigation. In the figure 8, you can see time variation of rainfall and generation of groundwater level data. Accordingly, I categorize into 3 stages. Figure 8 shows the time variation of surface displacement data. As I explained, you can see the changes of surface displacement with the generation of groundwater level. The relationship between velocity and acceleration, figure 10 shows the relationship between velocity and acceleration for 3 stages. Mainly here you can see prior to mitigation and during mitigation, the linear relationship we observed is identically same, but comparing these both, the relationship got for the after mitigation is shifted downward as parallel to the previous ones. Table 1 shows the constant A and alpha values and R values derived from the linear relationship. Accordingly, you can see especially A value is more decreased comparing with other 2 stages. These results of the velocity and acceleration relationship gives the clues of relative activity of landslide. In the prediction of failure time, comparison of time variation of time remaining to failure was carried out using the VAA method. Here the time remaining to failure approaching to 0 considered as an indicator for failure prediction. Figure 11, you can see the time variation of time remaining to failure. Accordingly, at the beginning, the data was fluctuated due to the insufficient of data. After that, during mitigation, you can see some general decrease in trend. And after the mitigation, you can see the increase in trend. These are the conclusions of my research study. The present study revealed that the linear relationship between velocity and acceleration could be well established. Second one is increase in trend of time remaining to failure in the stage of after mitigation reveals that dewatering and surface drainage improvement creates significant effect over the unstable soil mass. Third is the results of predicted failure time emphasize that necessity of issuing landslide early warning when any point time remaining to failure on the line of decreasing trend over time. Fourth, it is important to monitor the movement and changes with sensitive real-time monitoring equipment to get better understanding, and also insufficient data causes the poor accuracy of the prediction. These are the recommendations. First, obtaining of accurate measured time series surface displacement data for several selected slow-moving landslides is important for future analysis, studies, and landslide early warning purpose to implement the on-time monitoring system. Second, necessity of developing a site-specific relationship between rainfall intensities and surface displacement by back analyzing with the available data to establish the concept. These are my references. Thank you.
So thank you. So these are the 4 presentations. And we discuss about how the air and the rainfall variations, and then we discuss about how we can identify the cut slope from the LiDAR, and now we discuss about deformation. So if you have any questions from the presenters, you can ask now. So while we're reading, I can ask one question from Runuge, because you are predicting about episode. So you know that there are a lot of outliers in the rainfall, and when we're focusing on the weather. So how you manage these outliers from these episode calculations?
When we calculate in the average values, and when we going to extrapolate some kind of extrapolation techniques, when we going to use extrapolation techniques, there is a very base technique. We have to do the outlier test, and we need to identify what kind of outliers is there. So based on that, if there is any certain outlier, we have to remove it. Otherwise, we cannot do for extrapolation work, because the basic principle of the mathematics, if there is any data set, if we are going to derive any equation or a polynomial, we have to avoid the outliers. That is for the Z test or the quartile test, any kind of test we can use for the outlier omittings.
Okay. So if there is no question, so I can move forward. My next question is to Dr. Vasantha, because NBR has a lot of automated rain gauges. So how we can use this threshold value calculation from these all rain gauge sensors, like how we can extrapolate this work into other sensors to calculate various threshold limits for different districts.
Actually, this study mainly focused on the limited number of incidents and short time. We want to collect the several number incidents, and we want to get the associated rainfall to connect it with them. So this is the pilot study. Then we plan to continue it in near future. Then we hoped that to get the best results in future, because we have only 25 cases got this study. Then we actually the bias accuracy is also less, around 12%, because of the less amount of the sample. Then in future we have planned to continue this. Then I think then we can get the better results. So because our existing threshold focus on the entire 14 districts, then actually it varies with the soil condition, land use pattern, and other slope conditions. The only considered the rainfall triggering condition. Then here we have considered the seasonal rainfall. Then we have recent experiences. When we consider the Aranayaka landslide, the rainfall value was the only less than 60 millimeter, but calculating the seasonal, there was more than 600 rainfall. Then last year in June, we experienced again the incidents at Heliagoda. That day we didn't issue the warning, but the incident was occurred there. The rainfall, the cumulative seasonal rainfall was more than 500 or like that. So we want to consider seasonal rainfall also with the short-term rainfall. Then we have planned to continue the research in further.
All right, thank you. It's a very comprehensive answer. So if there are any questions from the audience? All right, one question from the...
Yeah, thank you, Dr. Basanta. When you define a threshold limit, I saw you put like a day value, that 75 millimeter per day. Whether it means a 24 hour. Once the starting point to the next point is 24 hour. Am I correct? But you define the threshold limits 75 millimeter per day and also 100 millimeters per day. So once you define a day, so that's some complication is there, whether it really means the 24 hour. Am I correct? In your presentation, you put like a 75 millimeter per day.
Can you explain
threshold
it again?
value?
Sorry, can you explain it again though?
Now, in your table, the threshold limit you define as a 75, first alarming is a 75 millimeters per day. And the second category you also define as 100 millimeters per day.
Yeah.
With it means a 24 hour. Am I correct?
Yes, 24 hours.
Yeah, because rain start at any time
In time,
to
yeah.
the next
We measured
24
the
hour
24
day.
hours, yes.
Right, okay, thank you.
Okay, are there any questions from the audience? Okay, if not, we can ask one more question from the panelists. I would like to ask from Dr. Imaya, because you mentioned that several deformations working on light noise mitigation side. How we can use this drone technology for your work? Like, if we can fly the drone routinely or in different time intervals, can we use that data for assess these kind of deformations?
For the analysis, we need a continuous data set. So it means time variation. So the data we obtain from the drone, if we have continuous data set, we can use for the analysis. Yes.
Okay, thank you so much. If we have no questions, we can wrap up, but there's one presenter here, so I would like to ask one more question from him as well. So you have mentioned that this is very ground application, so how we can extrapolate this work into other areas as well, because we are trying to capture some LiDAR data in a lot of districts now. So did you develop any GIS or any kind of model to extrapolate this work in other districts?
Yeah, currently we have developed a model and a tool in what we can use in ArcGIS Pro. So we can use this model tool, and after capturing the LiDAR digital terrain models, so we can run the tool and extract cut slopes in whole landslide prone districts.
Okay, so thank you so much, because we don't have much more questions from the audience as well, and I hope we complete all these presentations so far. And thank you so much. Thank you so much, all your presenters, and thank you so much for...
Thank you very much, our session chair, Planner Dayan Munasinghe, for your leadership and guidance for this technical session, and our presenters for their insightful outputs and their dedications. So our sincere appreciation also goes to all of you.
Now, let us take a moment to recognize the outstanding efforts of our presenters. Each of them has contributed significantly to today's session, sharing their research findings and insights with clarity and passion.
So to honor their participation, now we invite our session chair, Planner Dayan Munasinghe, to join us on stage and present the certificates to the presenters. Presenters, as your names are called, please come forward to accept your certificates. Mr. R.R.D. Ruhunage. Dr. KPG W. Senadira. Mr. P. Vikram Singha. And Dr. Imaya Ari Ratna.
Before we conclude, I would like to invite our session chair, Planner Diane Munsinger, to remain for a brief moment. And I would like to invite Mrs. Kumudu Randeni, Directress of the Finance Division, NBRO, to present the token of appreciation to Planner Diane Munsinger for his exceptional leadership throughout the session. Thank you.
Once again, thank you to our presenters and our session chair for their invaluable contributions.
As we approach the conclusion of this remarkable research symposium, it's my privilege to invite Mr. Chintaka Ratnasiri, Acting Director of the Human Settlements Planning and Training Division at NBRO, to formally conclude the symposium and deliver the concluding remarks.
Okay, good evening, everyone. First of all, I would like to thank you all for being with us till the end throughout the day, and hope this symposium was a very productive one. So, on behalf of the organizing committee, let me conclude the proceedings of 14th Annual Research Symposium of the NBRO. We conducted under the theme of Smart Solution for Built Environment Resilience. So, we conduct this symposium annually, as you all know, aiming to disseminate research findings and technology innovations, and also to build strong network with our partner agencies and the professionals in order to enhance our capacity in addressing our built environment challenges. So I hope this discussion should continue further, and we should together come up with some solution to address our issues. So this morning, Honorable Deputy Minister participated as the chief guest and addressed the gathering, and we thank him for attending and conducting his valuable speech. And also, we highly appreciate the participation of Secretary of the Ministry of Defense this morning, and joining with us this under the until complete the inauguration session. And also, we express our sincere thanks to Mr. Ajit Abesekara, who delivered the keynote address in this today's symposium. And he emphasized the significance of achieving built environment resilience as a prerequisite for a sustainable development and the economical stability of the country. So, as the professionals, we have a huge role to play in achieving sustainable development, also to support the economic growth of the country. And then the NBRO Research Award 2024, the first time in history, we had that sort of systematic research award launched at the very beginning of 2024. The prime objective of the NBRO Research Award was to encourage our scientists at the NBRO to pursue high quality research in the area of resilient built environment. So we are really happy that we were able to publish 34 full papers and also award 3 best papers. So while appreciating all the authors and all the winners, and also I would like to congratulate all the winners of the best paper awards, and hope they will come up with very productive and innovative ideas in this year too. And then we had a very wonderful panel discussion this morning under the main theme of symposium, the Smart Solution for Built Environment Resilience. So I appreciate the participation of the session moderator, Professor Uday Nawagamu, and Mr. Sakurasawa, also Professor Tilak Kewasam, and also Professor Narayan Pereira, and Mr. Hevin Jayveer. So when we talk about a smart solution, the key terms that comes to our mind, that IoT, AI, machine learning, the sophisticated software thing. But what our panelists highlight this morning under the session session, so some keyword that I wrote down was the legal framework development, building regulation, building code, importance of biodiversity, forestation, and addressing this local climatic condition, education awareness. So I think that panel discussion, the conclusion, they provide us platform for us to rethink about how this smart solution and addressing this, what they mentioned is, I think, very important to rethink what is the smart solutions are really. And then we had a very interesting 3 technical sessions, and under the 3 sub-themes. So I would like to, we present 12 full research papers this evening, this afternoon. So I would like to thank all the 12 paper presenters, and also session chairs, Dr. Dhanushka Jayatilaka, Engineer Dr. Sanchit Jayakodi, and also a planner to be doctor in 3 weeks, Planner Diane Munasinghe. So for their wonderful commitment today. And on behalf of the Symposium Organizing Committee, and I express our deepest gratitude to JICA. I think that JICA technical collaboration is one of the very successful partnership we had for more than 1 decade of time, I think. So it enhances the capacity of NBRO at a different scale. So I take this opportunity to thank JICA for their wonderful support extended to NBRO. And also I take this opportunity to thank all the participants representing public sector and the private sector agencies, universities, professional bodies, international agencies, and NGOs. We highly appreciate their support and the collaboration with the NBRO. And finally, I wish to thank all the supporting staff who worked hard for the last 2-3 months to make this event a successful one. And also, I take this opportunity to thank all the technical service provider and this hotel staff as well. So let's meet again at the 15th Annual Research Symposium of the NBRO. Have a great day. Thank you.